Today I'm going to have a look at the IPCC Intergovernmental Panel on Climate Change 2014 Synthesis Report. So this report's been out for a couple of years, but I've been trying to read it a little bit recently, and so I'll tell you what I have found in it as I've been reading it. This is the big report from the UN, and it's talking about, the major factors of climate change. It actually has some pertinent points, so I'll see if I can work out how to navigate this document. Find an index. I don't know. I will just page down through it. Okay, right, here we go. So we've got some index here, and there was a particular thing that I found interesting, so I haven't looked at this for a couple of weeks, so I'll just try and find I think the bit that is interesting is there's these things called adaptation pathways. There we go. So I'll see if I can find the graph that explains the adaptation pathways. Oh, right, here we go. So you can see that this is a graph. So these show you these things called adaptation pathways, or greenhouse gas emission pathways 2000 to 2100. So what they did is they made some scenarios under what we'll end up with what we can pollute. And my understanding of these is, if we look at this black one at the top, you can see that it's called RCP 8.5, and I think this is the greenhouse gas emissions that will lead you to 8.5 degrees of warming average. And this, I'm going to call it purple one, RCP 6, is the emission profile that will lead to 6 degrees of warming. And down in the floor, in the orange and the blue, is RCP 4.5 and 2.6. So 2.6 leads you to 2.6 degrees of warming. And over on the left-hand side, we've got the annual greenhouse gas emissions in gigatons of CO2 equivalents per year. And the interesting point is that to get RCP 2.6, you need to have no emissions. So if over the next, where do we get down to? About nothing. About year 2080, we're getting back under the red line of the zero, which is no emissions. But so that's saying that if we curve off our emissions in the year 2020 and start declining in the year 2020 and follow this best pathway down to RCP 2.6, we still end up with 2.6 degrees of warming over the 80 years that comes after 2020. But also it's about saying we're getting 2.6 degrees of warming if we follow that down slope pathway down to 2070 as well. And for a lot of people, these times are just far off in the future. However, if you've got children and are born around now, so let's say that the year's 2017 now, we'll just to make the maths easy, we'll just say children born in the year 2020, by the time they're 50 years old, that will be 2070. And so to be on this emissions pathway that leads to 2.6 degrees of warming, then we have to be on this basically ever decreasing amount of carbon dioxide emissions. I'm only going to talk about RCP 2.6 because it's the only one that matters. All of the RCPs that are higher than 2.6 are, I'm going to use the word, devastating to the planet. So RCP 6, RCP 8.5, and RCP 4.5 are effectively unlivable situations. That's the problem. They don't really mention that you know how the Paris Agreement was talking about 2 degrees of warming. You see, the 2 degrees of warming is a livable amount of warming. That's an amount of warming where most people will not die due to this problem. And the reason why I've got this sort of like bemused, amused tone in my voice is because The problem is the problem is literally unbelievable for most people. I'm gonna flick down through some more pages. I don't know. I'll just read this bit in bold. What does it say? Limiting warming to a likely chance of less than 2 degrees relative to pre-industrial levels would require substantial cuts in anthropogenic greenhouse gas emissions. That means we need to cut our pollution that comes from burning coal, gas, petrol, diesel, liquid and solid fuels. By mid-century, through large-scale changes in energy systems and possibly land use, limiting warming to higher levels would require similar changes, but less quickly. Limiting warming to lower level would require these changes more quickly, and that's with high confidence. So, effectively, scenarios that are likely to maintain warming below 2 degrees, which is the Paris Agreement, are characterized by a 40 to 70% reduction in greenhouse gas emissions by 2050 relative to 2010 levels. So to stay in what I'm going to consider livable, when I say livable, I mean economically livable. There's some people who would survive this, but when I say livable, I mean livable for everybody who's currently around. We don't want to, metaphorically throw some people under the bus, because not all people will be able to recover. And then on the next page, this table 3.1, key characteristics of scenarios collected and assessed for the AR5 report. All parameters are 10th to 90th percentile of scenarios is shown. What does this mean? In this table, we have these RCP pathways. So on the bottom half of the table, there's RCP 4.5, 6, and 8.5. I'm going to call those ones the unlivable ones, and the RCP 2.6, which is the one right at the very top. What we have is we have this thing where anything better than RCP 2.6, only a limited number of individual model studies have explored levels below this level. I think the reason why they're not exploring things below that level is because simply things below that level are literally impossible. We don't have the desire or ability to change that quickly. But if you look in the center of the table, there's a big blue box which says unlikely. And so if you look at the 1.5 degrees C, it says likelihood of staying below specific temperature levels over the 21st century relative to 1850 to 1900, which is the pre-industrial period. And so in the 1.5 degree column, we have at the bottom, unlikely, unlikely, and more unlikely than likely. So this is saying that it is unlikely under any circumstance that we would be able to stay under 1.5 degrees. And then in the next column, the 2 degree column, we've got, going from bottom to top, we've got unlikely, unlikely, more unlikely than likely, about as likely as not, more likely than not, and likely. So if we go along the RCP 2.6 degree pathway, then that's the only circumstance where you're able to control temperatures to not more than a 2 degree circumstance. So this is an important thing to know. If we follow RCP 2.6, then we're able to stick to the Paris Climate Agreement, so that's possible. And then we'll just look at the 3 degree. I'm going to exclude the 4 degree because 4 degree is what I consider to be an unlivable scenario. That's a scenario in which case climate change causes so much damage that we'll have economic or food production losses that are so severe that for many people in the world is effectively unlivable. And I mean unlivable continuing in our current state of civilization. So we'll wind back to level 3. So in 3 degrees, the likelihood is if we stay in anything below the RCP 4.5, then we'll end up with it's likely to stay below 3 degrees. But I still think that 3 degrees is effectively an unlivable planet due to economic problems, food shortage problems, or just other problems like storms or whatever affecting too many people too much of the time, that everything just continuing with civilization is more of a hassle than not continuing with civilization. So we've got that problem. So the only viable one is the 2-degree one and the likely, which means that you have to stay in this RCP 2.6 pollution range. So I'll just roll back up to the previous graph. So in the RCP 2.6, which is the only desirable solution at this point in time, it actually shows flat and then diminishing emissions from year 2020 or around 2022. I can't quite tell on the graphs, too many lines in there. So we're looking in the, if you look above the 2020, find the black lines, then follow the black line that diminishes all the way down to RCP 2.6. That's the only pathway that is an acceptable pathway that allows us to continue living on the planet in much the same way as most of us are living now. What's the conclusion of that is the important thing. What does that actually mean? Well, that means we decrease fossil fuel burning forever and a lot. And not only do we decrease it forever and a lot, we have to start decreasing it really, really, really soon. Because if you don't start decreasing it really, really soon, you'll end up on the RCP 4.5 or the RCP 6 track, which, as I've said earlier, we already consider those to be unlivable solutions. So they're not real options. They're not options that anybody will want to live with. I don't know if this goes on to say anything more useful. I mean, it does say a lot of things that are more useful, but you end up just getting into so much science talk that it becomes unintelligible for a lot of people. So this is on IPCC.ch website, so you can download and have a look at the report. This is called the Synthesis Report, and this is the report that's meant to have the simple and straightforward answers in it. But for a lot of people, being able to read these reports, even for me, I'd done science. I even studied environmental physics when I was at university. So not that I'm not an environmental physics expert. I have a rough understanding of the concepts of environmental physics, and I find this a bit heavy. So what I'm going to say is, what does phasing out of these fuels look like? Well, it looks like the way that you could do this is to fly no jet airliners that are powered by normal aviation fuel, and drive no cars and trucks and SUVs, all the normal vehicles that people drive every day. It looks like driving none of those. It also looks like phasing out all coal power plants and phasing out all natural gas power plants. And if I just roll back down to the graph, so you can see what that phasing looks like. It looks like not even level over the next decade. It looks like a decrease from 2020 onwards, ever decreasing. And so by the time you go from 2020 to 2050, you're already getting around to half of the emissions. So 2020 to 2050 is just 30 years. And so what does this mean? Because the graph plots for diminishing from about 2020 or 2022 onwards, so in most countries, cars are kept for, let's say, just 15 years. Maybe if you're in a really advanced country like Japan, people might keep their cars only for an average of less than 10 years. But in New Zealand, where I live, we keep our cars for an average of about 14 or 15 years, which means half of the cars are older than 15 years and half of the cars are younger than 15 years. So after 15 years, if we replaced all of our cars with only electric cars, that would mean in 15 years time about half of the cars on the road would be electric cars. But because we aren't going to replace cars starting just tomorrow with electric cars, that means like we're going to phase electric cars in over the next 5 years. And I would imagine that effectively over the next 10 years we'll see complete phase out of all petrol cars. You won't see any new petrol cars being able to be bought anywhere. If you don't see this, however, it means that we'll be drastically failing this commitment to reduce the carbon dioxide pollution. So you'll be able to tell in 5 years' time if something's actually happening. Because if where you live, because I'm speaking English, I'm going to assume you're in an English-speaking country, probably most likely going to be in Canada, Australia, United States, New Zealand, or the United Kingdom. Those kinds of countries, you might be watching a lot of Dutch people speak English and a lot of German people speak English. What you'll see is if you don't see the vast majority of new cars being electric cars within the sort of next 5 years, then you can know that we are starting to fail. If in year 2025 you don't see that basically most of the new cars in your neighborhoods are electric cars, then you know we're completely failing this. I mean, in the Netherlands, they're phasing out petrol cars earlier than most places, I think. But even in New Zealand, where we have half of our new cars are actually just imported second-hand used Japanese cars. So cars new into New Zealand, we import a lot of Japanese cars. We should be seeing many thousands of electric cars coming into New Zealand. I mean, at the moment, I think we're at 2,000 electric cars per year. And we're halfway through 2017. Probably by the end of this year, we'll be at 3,000 electric cars per year. And then by the end of 2018, we'll be around 6,000 electric cars per year coming into the country. And most of those will probably just be used Japanese cars because it's very cost effective for us to do it that way. Yeah, so you'll be able to see if you're failing. Likewise, if you're driving around and you see new coal power plants and new gas power plants being built, then you can tell that you're failing because coal power plants, have a payback time of a lot of years, maybe a few decades. So any investment in coal now is a malinvestment because at the rate that we're going to have to reduce our pollution of coal fumes and even natural gas fumes, we're going to have to see most of these things being shut down and phased out before the equipment's worn out. That's the problem with cars. I would imagine that a lot of older cars don't get driven that many kilometers per year. We can make a big win by the new cars that we drive a lot. So the people who buy new cars and drive their new cars a lot, if they change to electric cars earlier, that gives us a big reduction in greenhouse gas chemicals. Anyway, I hope that explains something for you. It's quite a technical report, and I've been trying to read it and reread it. The key takeaway here is that if by 2025 people are still flying around in jetliners just as much as they are now, you can know that we are failing this commitment to reduce our greenhouse gas. And if by 2025 you don't see the vast majority of new cars being electrically driven, then you'll know that we are failing this. And if we are failing this, that means we're leaving that moderately safe but still bad 2-degree warming, and we'll be moving to this 4-degree warming, which will cause rather bad economic disaster because we're going to flood our giant cities because most of our big cities are at sea level. They're going to be flooded. We're going to have to move all of our houses that are near the beach to further inland uphill. That will cost a lot of money. So the costs of not mitigating carbon dioxide are extremely expensive. I just wanted you to know what success and failure along the way will look like so that you will know whether we are succeeding or failing. Thanks for watching and listening.